Okay, so let's take a look at this example here. This is from section 1.1. You can see it's asking us to solve the following equation. You've got x plus 3 over x plus 5 equals x minus 4 over x plus 4. So let's go ahead and take a look how we can actually go about solving an example like this. So there's two ways you can actually solve this problem. Obviously, the first process would be to find the least common denominator between our two denominators, x plus 5 and x plus 4. However, in this particular example, since you will notice we're not adding or subtracting another fraction on the left-hand side of our equation, and obviously we're not adding or subtracting any other fraction on the right side of our equation. So since I have only one fraction on the left and one fraction on the right, I can actually use cross product to solve this equation out. So all we need to do is go ahead and multiply our x plus 5 with x minus 4 and x plus 3 with x plus 4. So we'll actually go ahead and do our cross product in this way. And you will see this will come out to be x plus 3 times x plus 4 on the left-hand side. And then on the right-hand side, I will have x plus 5 times x minus 4. Okay, so once we set this up, what we will need to do, obviously, to solve this is go ahead and FOIL both sides of our equation. So we'll need to multiply this across, multiply these, so we will perform FOIL on the left-hand side, and pretty much we will come back and repeat that process on the right-hand side and do a FOIL there as well. So here I will end up getting x times x, which is x squared. X times positive 4 will be 4x. 3 times x will be positive 3x. And then, of course, 3 times 4 will be a positive 12. Okay? Let's go ahead and repeat that same process on the right-hand side. We will do x times x for x squared. X times negative 4 is negative 4x. 5 times x will be 5x, and then 5 times negative 4 will be negative 20. Once we do that, on both sides of our equation, we will go ahead and combine our like terms. So this will end up giving us x squared plus, we're adding 4x and 3x. Of course, that will add up to 7x plus 12. Repeat the same thing on right-hand side. So that's x squared. Negative 4x plus 5x will be 1x, or just x, minus 20. Once you get down to this stage, all we have to do now is bring the like terms on the same side of the equation. So of course you can see I have an x squared term here, an x squared term here. So let's go ahead and move them on the same side. So I'm actually going to go ahead and subtract this x squared, bring it over to the left-hand side, and as you will see, our x squares will cancel each other out. So you've got x squared minus x squared, x squared minus x squared, and they will basically disappear. Now, repeat the same process with your x terms. So I've got a 7x here, 1x here, so I'm actually going to move this guy to the left-hand side. This will become minus x. Subtract x here. Of course, on this side, your x will cancel out. And on the left-hand side, 7x minus 1x, of course, will give us 6x. Bring this 12 down. And then on the other side of our equation, of course, you will see our x squares and x's canceled out, leaving us only with a negative 20. We will repeat that process again. Since I brought my x term here, I'm actually going to take the 12 to the other side. So subtract my 12, move it to the right-hand side. And again, my positive 12, negative 12 cancel out, leaving us behind with 6x on the left-hand side. And then negative 20 minus 12 will actually become negative 32, right? So now all we have to do is get the x by itself, divide both sides by 6. You end up with x equals negative 32 over 6. As we do with any fractions, we want to reduce this. So between negative 32 and positive 6, the only thing that will be common is the number 2. So go ahead and divide both your numerator and denominator by a 2, which will end up giving us negative 16 over 3. Okay, so as you can see, 3 of course will not go into negative 16. And so all we got to do now is go back into MyMathLab and check to see if this would be our answer or not. So let's go back into MyMathLab, and the solution set is negative 16 over 3, and let's check that answer. And you can see that will work for us. So I hope this helps you out in solving this example from section 1.1. Thank you.